Assalamu alaikum, this is Dr. Bilal Majid. So this is a set of series of lectures on machine learning, or you could refer to it as pattern recognition or artificial intelligence. Now the contents of this particular course is that of a graduate program. At the same time, if you're an undergraduate and you're looking at these videos, then they're equally applicable to you. So I would be teaching all the contents, inshallah, for a graduate course in machine learning or pattern recognition or artificial intelligence. At the same time, I would be presenting it in a way that even undergraduates should be able to follow and follow this up through. So machine learning is broadly, there are two frameworks associated with it. One is called regression, whereas the other one is called classification. Now, as far as classification is concerned, earlier on, a couple of years ago, within electrical engineering or signal processing, the same machine learning was called estimation and detection theory. In the sense that, for instance, if there's an aircraft, how do I draw an aircraft? Let's say if there's an aircraft flying through a particular airspace, the first thing you have to do, or let's say there's a missile flying through an airspace, the first thing you have to do is to detect it. In the sense that you have to detect whether it's a friend or a foe. Although if it's a missile, you're probably most likely it is a foe. Otherwise you would know it's in the airspace. So if there's a missile, you first have to detect it, and then that this is a missile, it's not an aircraft, it's not something else. The first thing you have to do is detect it. But once it's part of your airspace, then you have to estimate it. The estimation is what is the trajectory, or where is it going to land, how fast is it going, how much time do we have. So that's part of, and broadly speaking, this particular course, and it's still taught in electrical engineering, this course was referred to as detection, because that's what you do, and estimation theory. Excuse me. So machine learning is referred to as, you could refer to as pattern recognition, or you can refer to as artificial intelligence, or you can refer to it as detection estimation theory, or data analytics, or whatnot. So this particular component of detection is what is referred to as classification. Given a particular data point, let's say if this is your area where you live in, okay, and these are the different houses, or let's say these are different, then what you have is, given a particular data point, in which case this, then let's say you live here, this is where you live. A simplistic example of estimation is that people who are close to you, will you refer to as your neighbors or your neighborhood, whereas houses further from you are not part of your neighborhood. And in that sense, what you have applied here really is any particular data point which is given to you, you're going to map it, and determining on how far it is from your house, you can classify whether he is a neighbor or not a neighbor, where this is the complement. Now this here is what is referred to as your decision boundary. This is referred to as your decision boundary, because this here is the deciding boundary. So if you're present below it, it's part of the neighborhood. If you're present beyond it, it's not part of the neighborhood. So let's say you're sick here and the government wants to have it, and it's an infectious disease, and the government wants to have a quarantine zone around you. They will probably, they might actually include some of your neighbors as well in the process. And the decision boundary, in fact, has been determined using a distance formula, right? So people who are closer to you or closer than a particular threshold tau, so if the distance between your house and the other, so this is your house and this is any other house, so this is the ith house and this is your house, if it is less than or equal to tau, then it is part of your neighborhood. If it's greater than tau, then it's not part of your neighborhood. Hence, notice there is a circular metric which is drawn here, right, where you being the center of that radius, and the whole decision boundary in fact could be something like this, where, this is more like the center here of this. So if you're living here, this is the distance that would be measured. Anything beyond that is not part of the neighborhood. So at some sense, this is what is referred to as a classification problem, where any given data point, you have to classify whether it's class A or class B. Now it doesn't have to be a binary problem, because if it's class A or class B, there are two classes, and hence this is called a binary problem. You could have a multi-class problem in which you can have multiple classes, and you have to determine which particular class that particular data point belongs to. So that is classification. Whereas regression is you have to determine I'm going to rub this off real quick. In regression analysis, you are interested in determining the pattern of a particular line, for instance. So let's say if you're going to talk about infections, let's say these are the number of infections. I'm using the example, these are the number of infections and this is the number of days. And let's say you're talking about a virus, COVID-19, which is the coronavirus, and these are the number of infections. So it starts like this, then 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 this. And you have to determine what is going to be the number of infections. Let's say if it's day, I don't know, 30. So you're going to plot all these lines, and then you're going to determine a line. What is the pattern? What is the equation of this line? So you're going to draw it. This is not a very, this is one particular example. Then using this formulation, you can determine on the 30th day, you'll probably have these many number of infections. This determining the line, determining the equation of this line or this curve is what is referred to as a regression problem. Now notice here that the line does not pass through these points. In fact, if you draw a line, something that actually passes through these data points, you won't actually get a straight line. You'll get a kinky top sort of line like this. Now this is in fact called overfitting. This is called overfitting the problem. You can actually even determine an equation of a line. It could be something like a curve that passes through all these lines, but then you don't. Then it's going to go something like this. So that is called overfitting. If your line passes through all the points, that is usually undesirable, because then you have overfitted your model to the current data set. Hence, you may not be able to better predict unknown data points. So usually a line like this is better off. This is called a regression problem. Now, hence, machine learning is really a component of two studies. One is called classification, whereas the other is called regression. Now in this particular course, I will be discussing both. I'll be discussing both elements, and we're going to start primarily from the classification, and then within some of the lectures we might introduce we will probably inshallah add some parts of regression, and then we'll try to take it together. So that's it for now. Thank you very much. Have a good day.